Okay, guys, this is our last lesson for our first unit. So we're going to keep going on inverses. Again, the main idea when I want you to hear the word inverse is I want you to think of the word switch and the two different ways that we write inverse. So if y equals f of x is the original, then we show the inverse in one of the following two ways. We'll either show it like that, or we will show it like that. So there's three things that you need to know about inverse. You need to know how to graph, you need to know how to find the equation, and you need to understand about domain and range. So using the idea of switch, in order to graph, what you do is you switch all the coordinates, then you reflect across the mirror line, which is y equals x, and graph your new image. And it should look like you took your paper and bent it across that mirror line, and the image is in the new spot. For finding the equations, what you do again is you switch the x and y letters around, and then you get the new y by itself. So if this idea of switch can be applied to graphs, and it also can be applied to equations, then the last thing we can do is we can apply it to domain and range. Because remember, domain is a set of all x values, range is a set of all y values. So the domain of the inverse is the range of the original. The range of the inverse is the domain of the original. So you're just going to switch domain and range as well. And also the inverse of a function may or may not be a function. So if it is a function, we write it like this. If it is not a function, we write it like that. Okay? Okay, so it says some relations are functions and some are not. The inverse of a relation which is not a function can also be determined by the above methods. Consider the relation, blah, 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 whose graph is a circle with a center at 3, 0 and a radius of 3. So if I go out 3, up 3, back 3, down 3, and then if I connect that, we get out a circle. So describe how to use the graph of the relation to draw the graph of the inverse. So again, what we would do is we would take our points. So we would take 3, 3, 6, 0, 0, 0, and negative 3, 3, and we would switch them all around. So we'd have 3, 3, 0, 6, 0, 0, and positive 3, negative 3. Just rewrite that one. Now, one thing I want to draw your attention to is this point and this point. These 2 points are what we call invariant. Again, they did not move. Okay, so when the x and y coordinates are the same number, they do not move. Okay, so I'm just going to plot those points. So 3, 3 is going to stay the same. 0, 0 is going to stay the same. 6, 0 becomes 0, 6. And 3, negative 3 becomes negative 3, 3. So now when I connect those, there's my circle. And if I draw in my mirror line, you should see how the blue reflects to the red. So using my mirror, my magic pen here, so this part of the blue is going to become this part of the red. It's reflected across that green line. I'm just going to wait for that to disappear. And then this part of the blue becomes this part. Whoops. Becomes this part of the red. Okay? So again, you should be able to see that reflection happening. So describe how to use the equation. Okay, so if I wanted to find the equation, what I would do is I would just switch the x and y coordinates around. Okay, and I would get that y by itself. So I'm going to start off by minusing x squared from both sides. And then I'm going to square root. And then I'm going to add 3. Now, if I look at my red graph, so if I look at my red graph, my red circle, if I were to draw a vertical line through it, is that a function? No, it is not. So the way I'm going to write the answer is I'm going to write it as y to the negative 1 equals. Now, one more thing I need to talk to you about is square roots. So just off to the side here, I'm just going to insert a page. So when you take the square root of 16, almost all of you can tell me the answer is 4. Reason? Because 4 times 4 is 16. Well, what else squared also gives 16? The answer to that is negative 4. So when we take the square root of a number, there's always actually two answers, a positive one and a negative one. So when we're doing inverses, and this is for inverses only, when you're doing the equation of inverse, so in your process, if you have to insert a square root, then you must insert plus minus. So here I inserted a square root to get rid of the squared. So because I inserted a square root, then I have to insert plus minus in front of it. So if you don't write that plus minus in, it is wrong. Okay, it has to be inserted in there. Okay, let me just, okay, so domain and range. So if we look back at our original, the domain, so it has a left side and a right side. So the left side, left x was 0, the right x was 6. The range, bottom and top. The bottom of the graph was at negative 3, the top of the graph was at positive 3. If we look at our inverse graph, we can see that the left side of the graph is at negative 3, and the right side of the graph was at positive 3. For the range, the bottom of the graph was at 0, the top of the graph was at 6. Notice what's happened here. So the domain of the original became the range of the inverse. The range of the original became the domain of the inverse. All I had to do was switch the x and the y. Okay? Okay. So let's just practice this idea of solving equations. So determine f to the negative 1x. So again, sometimes on the test it won't even say, you won't even see the word inverse. You'll just see the notation, so you'll have to know that means inverse. So again, f of x is the same as saying y. So our first step is to switch that x and y around. Now we want to get the new y by itself. So I'm going to add 3 to both sides. And then I'm going to divide both sides by 2. Okay, so again, I would write it as f to the negative 1x. Now, writing it as x plus 3 over 2 is perfectly fine. The other way that you could write it is to recognize that there's a 1 in front of that. So because I have a binomial on the top and a monomial on the bottom, I can separate it up. So I would have 1/2 x plus 3/2. So both of those are equally correct answers. Okay, so f of x equals x cubed plus 4. So again, start out by switching the x and y around. Now I have to get the new y by itself. So I'm going to start by subtracting 4 from both sides. Now to get rid of a square, we would square root. So to get rid of a cube, we cube root. Now, as I discussed on the last page, when you insert a square root, you have to insert plus minus. When you insert a cube root, you do not insert plus minus. The reason why is if I asked you for the cube root of 27, that would be 3 times 3 times 3, so it equals 3. If you try the negative 3, Well, negative 3 times negative 3 times negative 3 is negative 27, so that does not work. So cube roots only have one answer. They only have, so you don't need the plus minus in front of that. Okay, so again, switch the x and y's around and then get the new y by itself using whatever algebra methods necessary. Okay, so it says consider the function f of x equals x to the x squared minus 4. So graph that. So notice here my scale, everything's counting by 2's. So if I were to just graph this, again, using my calculator, I get out a pointer at -4, another one here at 2, and another one here at -2. And again, I'm just saving time here. I already know what the picture is going to look like, so I'm just quickly doing it, but you could easily plug it into y1. So graph that and on the grid and state the domain and range. So because it's going to continue getting wider forever, the domain is x is all the reals. For the range, the bottom is at -4, but it has no top, so it's all the y's bigger than -4. So determine x equals f of y. So again, that is the shorthand for inverse. And solve for y. So we're going to start by switching our x and y's around. And then I'm going to get that new y by itself. So I'm going to add 4 to both sides. Now, because I'm working through inverse, I have to insert a square root. So when I insert a square root, I also have to insert plus minus. Now, to graph that on the graphing calculator, what you actually have to do is you have to put it in as 2 separate statements. So we're going to go the square root of x plus 4, and then you would go negative square root x plus 4. So when I graph that, I get out that image. Okay, so I'm just going to draw it all the same color. So -4 would be here. Now I could also find the picture by simply switching the x and y coordinates around. So 0, -4 would now be -4, 0. 2, 0 would be 0, 2. -2, 0 would be 0, -2. So you can see that my image there matches what I just did on the calculator. Now, the last thing is doing notation. So is that red graph, is it a function? Well, if I take a vertical line through it, notice the vertical line crosses it twice. So the red graph is not a function. So I have to show it as y to the -1. Okay, state the domain and range of the red graph. So the domain, the left is at -4, but it has no right. So it's all the x's bigger than -4. For the range, it has no bottom and top, so its y is real. Now just take a second and compare that to this answer right here. Notice they are switched. Okay, so the domain was x is real. Now that is the range. The range was y is greater than -4. Now that is the domain. Okay, last question with this, on this example, is it says, is the inverse of f a function? No, it's not. So it says, if not, how could the domain or range of f be restricted so that the inverse of f is also a function? Okay, so this is a question that the diploma does like to pick on. It's essentially saying, look, here's my original graph. And when I inverse it, I get out this. Okay, this one is a function. This one is not. So what could I do to this graph to make it into that graph? So they want us to limit it. And essentially all you have to do with quadratics is split them in half, or in other words, find the vertex. So the vertex of this graph was right here at 0, -4. So if my original graph had just been this portion right here, then that would have been just this portion right here. And if I had graphed just this, would that be a function? Yes. So one possible answer is to limit my original to just all the x's greater than 0, just to make that the domain. Now the other thing I could have done is I could have made my original just this portion of the graph. If I had done that, so again 0 comma negative 4 becomes negative 4 comma 0, negative 2 comma 0 becomes 0 comma negative 2. It would have become this. Now, is this a function? Yes. Is this now a function? Yes. So the other answer is I could have made it all the x's less than 0. So that is what it wants you to do, is it wants you to take the graph, your original graph, and break it into chunks so that when you do the inverse of that chunk, you now get out a function instead of a relation. Okay, so it says Don incorrectly determined the inverse of the function defined by y equals square root x minus 3 to be the equation x squared plus 3. He graphed the inverse of the function and obtained a parabola. That's another name for a quadratic function. Explain why Don's equation of the inverse is not complete and why the graph of the correct inverse is not a parabola. Okay, so what he did was his original was y equals square root x minus 3. So if I were to just find the equation, I would start out by switching my x and y's around, okay? And then I would square both sides to get rid of my square root. And then I would add 3 to both sides. So that's how he got his inverse equation. So he didn't do anything wrong mathematically. So let's look at the graph. So if I graph the original on my graphing calculator, y equals square root x minus 3, I'm going to get out this image right here. Okay. When I graph this on my calculator, I get out this. Now you can clearly see that the red is not the inverse of the blue. So the reason for that is it's based on domain and range. The domain of this graph is all the x's bigger than 3, and the range is everything bigger than 0. So remember, for my inverse domain and range, I'm just going to switch my original domain and range. So my original domain is going to become my new range. My original range is going to become my new domain. So when I look at this now, okay, this is the image, but it says x has to be greater than 0. So this is the only part of the graph I'm allowed to give. I'm not allowed to graph that part because these x's are less than 0. These x's are greater than 0. So what you have to do is you have to say that this is the equation, but x must be greater than 0. So you have to put that part on the end so that you only end up with the correct portion of the graph that you want. You only end up with this portion. You don't want to have this portion on there. Now when I erase that, you can clearly see that if I were to graph that and flip the points and flip it over that green line, that they would be the inverses of each other. Okay, so you can't just trust the math. All these pieces play together. So the inverse graph, the inverse equation, and the inverse domain and range all have to match. Okay, so you can't just do them in isolation. You have to be thinking about all three all the time. Okay, so let's skip that question. Let's do this one. So it says restrict the domain of the following functions so that their inverse is also a function. Okay, so we're going to pretend that all this counts by 1. So right now, if I were to do the inverse on this entire picture, okay, that graph would not be an inverse, would not be a function. Okay, so if I were to flip all those points around, so if I just do that off to the side here, I don't want to do it on that image. I'll explain here in just a second. So 1, 2, 3, 4, 5, 6, 7, 8, negative 6, negative 2, 2, and 3, and negative 2, 0, 3, 6, and 7. Okay, so negative 8 comma 7 is going to become 7 comma negative 8. Negative 6 comma 3 is going to become 3 comma negative 6. Negative 2 comma 3 is going to become 3 comma negative 2. So again, connecting these as I go. 0 comma 6 is going to become 6 comma 0. 2 comma 0 is going to become 0 comma 2. And 3 comma negative 2 will become negative 2 comma 3. Okay, so you can see by this picture now, this is the inverse. And if I were to take a vertical line through this graph, notice it is a relation, it's not a function. So on that last question that I did, it was a quadratic and we cut it in half through the vertex. However, there's no vertex on this thing. Whoops, what did I do here? There's no vertex on this thing, so I can't cut it through. So what I need you guys to do is I need you to break this graph down into mini chunks and say, okay, if I were to just do this little chunk, would this chunk be a function? So what if I were to take this little part right here? So that little part right there would be this little part right here. So is this little part right here a function? Yes. So one possible answer is I could restrict my domain just to go from negative 8 to negative 6. Okay. What else could I do? Well, I could also restrict my domain from here to here. So if I took that, that would become this. Now, is that a function? No, it's not. So that one doesn't work. Okay. What if I restricted it to this whole part right here? Well, that whole part right there would be this whole part right here. So is that part a function? Well, this is looking good, and then that's bad. So that's not a possibility either. So the next part would be this part right here. So that part right there would be this part right here. Is that part a function? Yep. So another possibility is going from negative 2 to 0. Okay. What's another possibility? Well, another possibility is going from negative 6. Sorry, from 6 down to that other point. So from 6 down to that other point would be this part here. That is a function. So another possibility is to go from here to here. So that would be from 0 to 2. Okay. Now what if I combined? Could I go from here to here? So could I go from there to there? Well, again, no, you can't, because that part there is not a function. Another part, could I go from here to here? So that would just be this little part right here. That is a function, so yep, that chunk works. So from 2 to 3. And then lastly, could I go from here to here? So that part's a function, that part is a function. So yes, that's another possible answer. So I could go from 0 to 3. So what they like to do on the diploma is they like to give you several statements and they'll say how many of them are true, or if they have the statements numbered, they'll be which ones are true. So statements 1, 2, and 4, statements 3, 5, and 6, whatever they have. Okay, so dividing a function into smaller chunks to make sure that the resulting image is also a function is a big component of this. Okay, so here's another one. So feel free to hit pause and do this one on your own, or if you want, just keep watching. So here, this is at 1, 2, 3, 4, 5, 6, 7. So negative 8 comma negative 3, negative 7, 4 comma 3, negative 1, negative 1, 2 comma negative 3, and 5 comma 1. So again, if I were to just do that quickly off to the side, okay, so negative 8 comma 3 is going to be negative 8 comma negative 3 is going to become negative 3 comma negative 8. And then negative 7, 0 becomes 0 comma negative 7. 4 comma negative 4 comma 3 will become 3 comma negative 4. Negative 1 comma 0 will become 0 comma negative 1. 0 comma negative 1 will become negative 1 comma 0. 2 comma negative 3 will become negative 3 comma 2. 5 comma 1 will become 1 comma 5. And then it just stays at that one. Okay, so we can see right now again that whole image is not a function, so I would have to divide this up into several chunks. So I'm just going to list out what all those chunks would be. So if you did one chunk from here to here, that would be 1. So from negative 8 to negative 7. Another one would be from negative 8 to negative 4. Another one would be from negative 4 to negative 1. Another one would be from negative 4 to 0. Another one would be from negative 4 to 2. Another one would be from negative 1 to 0. Another one would be from negative 1 to 2. Another one would be from 0 to 2. Another one would be from 2 to 5. And that's it. Okay, now keep in mind sometimes on the diploma they will like to show it like this. Remember, left comma right. Okay, so they could also have all the answers shown in that format as well. Okay, so this concludes this unit. If you have any questions on anything, please don't hesitate to ask, and look to the video description for the assignment in the workbook.